Mr. Math Sensei, Mr. Sensei, and this is exponential functions day one. So first off, exponential function is usually written as y equals a b to the x. It could also be written as f of x, which just means y equals a times parentheses b raised to the x. So let's talk about those different variables. A is the initial value or the y-intercept. We usually talk about it as the y-intercept, but if we're doing a word problem, the word initial or start or where you begin. So the initial, the start, or the begin. But really, it's just the y-intercept. This is what it really is. But in a word problem, start or begin or initial. B is the number in the equation being multiplied. All right. Each time, not by each time, but each time. Okay, so we're multiplying 1.5 by itself, and it's actually being multiplied by itself each time. If b is greater than 1, the exponential function shows growth. And if it shows growth, that means it's going to look like that if it's showing growth. The rate of growth is b minus 1. This is going to be super, super important to us. Okay, and it looks like I lost a capture marker. Hold on, just that. Right. So the rate of growth is, you know what? Let's use blue so we'll be consistent. The rate of growth is b minus 1. And that's if b is greater than 1. If, on the other hand, b is less than 1, the exponential function shows decay and is decreasing. If it's decreasing, it's not going to look like that. Okay. That's an increasing function. A decreasing function is going to look like this, where it's going down. All right. So that's a decreasing function, and the rate of decay is 1 minus b. So rate of growth, b minus 1. Rate of decay, 1 minus b. Let's not get those confused. That's the one thing you need to be careful about. And x is the number of times b is being multiplied by itself. Is the number of times it's being multiplied by itself. It's also the exponent. Okay, before I get into asymptote, let's go ahead and drop into Desmos, and I'm going to go ahead and put that equation in there. Actually, you know what? Before I do that, let's go ahead and write that equation above it. Y equals a parenthesis b to the x. Well, that means a must be 4. It also means b is 1.5. And 1.5, well, that's greater than 1. 1.5 is greater than 1. So this is showing growth. The y-intercept is our starting point, or a, so I'm going to write it as the ordered pair 0, 4, where this is my x and this is my y. So we know that this function is going to go up because this is a growth. Because it's a growth, b is greater than 1, it's going to go up like this, and it's going to pass through that point 4. But let's go to Desmos and see what this actually looks like. I'm messing that up a little bit. Share. Stop share. That's not working. Try this one more time. If not, we'll have to restart this video. So share. Here we go. Okay, so I'm going to type in that equation, which was y equals, and then 4 parentheses 1.5 parentheses. We'll use the little table down here, and we're going to have to press the AB button. Now we'll type X. So there it is. So there's our graph. And look, it goes through 0, 4. Now we were going to talk about asymptote. Asymptote is a line that the curve approaches but never crosses. Well, I can see that I'm getting really, 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 really close to 0. It's like every time I go this way, we're closer and closer to 0. Here we're at 0.5. Here we're at 0.06. Here is at 0.002. 0.0007, but our asymptote is where we never get to. It's a line that we can't touch. I always think of MC Hammer, can't touch this. So in this case, we can't touch the y-axis, and the y-axis is y equals 0. So for the time being, I'm going to pull out of this. I'll come back to this in just a moment. So we're going to stop share, and we're going to say our asymptote for this equation, not that it asks us, is y equals 0. The next thing we want to do is we're going to make a t-chart of values. Actually, let's calculate the rate of growth of decay. Well, we know it's a rate of growth, so we're going to have to go b minus 1. So in this case, because b is greater than 1, we're going to do 1 minus b. So we're going to go 1 minus 1.5 equals 0.5. And as a percent, I multiply this by 100. So if I go 0.5 times 100, I end up getting 50%. And this is a rate of growth. All right, so our growth rate is 50%. The equation of the asymptote, we just said it was going to be y equals 0 because it's the y-axis, and it's always written as y equals some number. Well, the number we get close to is 0. Well, I want to make a t-chart for this so I can graph some points. So let's go ahead and do that. We're going to go back to Desmos, or at least try to. Hopefully it won't take me as long as it did last time. And we're sharing our screen. And instead of hitting the plus button, I'm going to hit this gear button, and I'm going to press the table. Okay, so at that point, I have some points, and we're only going to mess with the whole numbers, 0 and 4, 1 and 6, 2 and 9. Let's put a 3 in there and see what happens. And we got a few others, and now we're off the graph. So we only have 0, 4, 1, 6, 2, 9, and I'm going to go ahead and graph those or put those points in there. So we have 0, 4, 1, 6, 2, 9, and I'm going to put in, let's put in -6, just see what happens. Oops. Using the negative button, -6. And I get 0.35. I'm also going to record that point as -6 and call that 0.35. And we'll estimate about where that is, and we're going to draw our graph. So I'm going to stop the share, and we're going to plot those points on our graph. So our points are, we know we have 0, 4. We also have a 1, 6. We also have a 2, 9. And then we go off the graph. We also know we have a -6. And if this is halfway, so -1, -2, -3, -4, -5, -6, if that's half, we're a little less than half. And we know we have this curve like that. So that's our graph. It's not perfect, but it's good enough. That's all we really need to be able to do. Okay, our domain. Well, I have arrows going this way. So, and remember, domain is our x values. So negative infinity. And I also have an arrow going this way. So less than x, less than positive infinity. So in other words, all real numbers. And then our range, well, do we ever get to 0? No, we get close, but that's our asymptote. We get really close to 0. So 0 less than y less than infinity. But remember, we never have infinity written, just like we don't have it written here. We can't write it there. And we don't leave it in this direction. We have to flip it. So we have to have y is greater than 0, not greater than or equal to, because we don't ever touch there. We get close, but it never touches. All right, it approaches it, but we can't touch this. So y is greater than 0. Okay, the next one. Once again, our equation is y equals a b to the x. Oops, b to the x. Well, b is less than 1. If b is less than 1, this means this is going to be decay. We had growth before, but now we have decay, so we're going to be going down. We also know that a is 3. That means I'm going to be crossing right there at that point. Okay, so we know a is 3. B is 1/3. We also know our y-intercept. Our y-intercept is 0, 3, which is x, and this is y. We know that this is less than 1 because b is less than 1, then this is decay. If we calculate the rate of decay, we're going to go, well, rate of decay is 1 minus b. So 1 minus 1/3, which is 2/3. All right. And if I have my calculator, and I'm just going to get this out just to show you. 2 divided by 3 times 100, because we got to multiply by 100, and we get 66%. So 66.67%, because we always multiply it by 100 because we want this as a percent. Okay, we'll come back to the equation of the asymptote after we plot this in Desmos. So let's flip over to Desmos. And we had a 3 there, and here we had 1/3. And we need to zoom out. And there it is. And I'm going to zoom in just a little bit, not that much. There we go. And we see we crosses at 3 and we're going down. So we have a rate of decay, and that's what we expected. Let's go ahead and hit the gear. And we're going to hit the ask for the table. And we got a table. So at -1, we have 9. So -1, 9, I'm going to write that down. We also have a 0, 3. Then we have a 1, 1. And then we have a 2 at 0.333. If I put in 3, we get 0.111. And that's as far as we're going to go. So when I look at this, it's like, gosh, it gets closer and closer to 0. So that means our asymptote is at 0. So we never cross the y-axis. So y equals 0 is our asymptote. So our equation, our asymptote, the line that we never cross is the y-axis. So y equals 0 because it's always y equals some number. So let's go ahead and plot our points. Well, we know we have -1 and 9. We have 0 and 3. We have 1 and 1. We have 2. And if this is half, this is 0.3. And we keep getting closer and closer and closer, but we never get there. So I'm going to go ahead and try to connect those dots. And here we're going to go off the graph. And we're going to make a sharp curve. And we're never going to touch this. So our domain, well, our domain, this has an arrow, so it means it's getting wider and wider. So our domain is, and remember, domain is the x values, is negative infinity less than x less than positive infinity. So this is going to be all real numbers. The next one is our range. Well, we start at the bottom. Well, what's the lowest thing? Well, we never get to zero. So 0 is less than y is less than infinity. But we never have this part right here. We never include the infinity, so we have to flip it. And we have y is greater than 0. And it has to be a greater than because we never get to 0. Okay. Here we're supposed to identify a, b, and the y-intercept. Well, in this case, a is 2. That means our y-intercept is 0, 2. This is x, this is y. This is 1.25, so b is 1.25. B is greater than 1. So since it's greater than 1, this is growth. And remember, to find out what the growth rate is, we're going to go 1 minus 0.2, 1 minus B, which is going to be 1 minus 1.25 equals 0.25. We're going to multiply that by 100 to get it into a percent, and we end up with 25%. So we have a 25% growth rate. Over here, I don't see an A, but I have a number here. So this means this is a 1. So A is 1, which means my y-intercept is 0, 1. This is x, this is y. This is 0.67. And in this case, B is less than 1. If it's less than 1, this is decay. All right? Now remember, I wrote this the wrong way on this one. I need to come back over here. I should have done B minus 1. So this is 1.25 minus 1 equals 0.25. Okay? So that's B minus 1. And over here, I have to do 1 minus B. Sorry about that. So this is going to be, and I have to do that because B is less than 1. So 1 minus B. And so when I do that, I have 1 minus 0.67 equals 0.33. Once again, we multiply that by 100 and we get a 33%. And remember, because B is less than 1, this is a rate of decay. All right. Appreciate you watching. Hope that helps and look forward to seeing you on the next one. Thank you.